Hi folks. So in the last 6 months I've been doing quite a lot of research into microwave transmissions, and in particular I've been focusing on this one, which is the world record 304 kilometre connection between Italy and the island of Sardinia. So this article was published on the New Atlas website in 2007, and I'll just briefly go through some of what it says. So in August 2007, a new world record distance for a 5 GHz Wi-Fi link has been achieved by the Italian Centre for Radio Activities, or CISAR, and Ubiquity Networks, who are the manufacturers of the antennas in the equipment. So a leading innovator in outdoor wireless broadband solutions. The distance of 304 kilometres was established from Sardinia Island to central Italy, achieving data rates of about 5 megabits per second. So let's scroll down a bit to here. So it was from Mount Amiata in Italy, which is about 1,740 meters above sea level. It doesn't mention this in this article how high it was in Sardinia, but that's 1,300 meters, which I'll show you later. So it allows operators on Sardinia Island to stay in touch with their community on the Italian peninsula, and is sure to have a range of applications in the future of Wi-Fi technologies by incorporating super high frequencies at far greater distances than ever before. So then it says right at the end, this sentence: this link was particularly important because in the event of an emergency, it will provide communications with authorities for help. So that's an important sentence because it is inferring that it will be a stable link, not intermittent, as it would have to be if it was to be used for emergency communications with authorities. So it would have to be a rock solid, stable link. So the Italian radio engineers, CISAR, as mentioned earlier, they have their own wiki page, which is here. And if you scroll down to the history and awards section, there's a PDF that they produced, which you can download directly, which is here. So this PDF documents the day of installation, when they actually physically went to the two sites and mounted the antennas. So you can see there are pictures and simulations of the link, a little map to show where it was to and from, more pictures, more simulations. But unfortunately it's all in Italian, so I ran it through a translator, which did an okay job. There are some grammatical errors and you kind of have to piece some bits together yourself, but we'll go through it and we'll see what it says. So we'll start here. The high altitude of the two sites were playing in our favour because such a connection distance, 304 kilometres, using frequencies in the range of 6 GHz, is essential to having the optical range and the first Fresnel zone completely free. The fact that in the middle of the connection there were more than 200 kilometres of sea playing in our favour on the one hand, so we had to take care only to climb over the curvature of the earth, but to the detriment of the high reflection, I think that says. So here's the link simulation. I forget the name of the software that they used, but I have got the software and I have duplicated this link in that software. So on the morning of June 16th, these guys, who seem to put their radio call signs everywhere, went near the Dell'Amiata station, which is the Italian site, while two other crazy known as Paolo Mauro and their call signs there, and took the ferry in the evening before to Sardinia to bring the material on the Limbara, which is the site in Sardinia, and meet locally these guys. In the morning, the weather was clear with large dark clouds that hovered around Amiata, but temperature was pleasant and good visibility. You could see the heights of the island. Now I can only assume they mean the other island. They could see one island from the other island, so they were in visual range. On Amiata, much of the work had already been done a few days before, thanks to the goodwill of these guys, and therefore remained only to point the satellite dish while the Limbara around 9 AM. They took off for work for the installation of the antennas. There's a bit of technical information there. So at about 1:30, after the installation of the material on Limbara, we proceeded the first brushed with our parabol to detect the beacon from the Sardinia. 2, I'm not sure where that's meant to continue, but never mind, we'll carry on. Because of the huge electromagnetic fields in Amiata caused by transfers by broadcast radio and television broadcasters, it was not even possible to contact our motherboard while having an Ethernet 10-meter long cable with ferrite cores inserted on both ends. We had to go to tracking, simply making us dictate by voice through the national link in speech the values received to Limbara. Upon receipt of the beacon, we stared at each antenna and the time left to friends in ISO disassembling the short backfire and connect them to the parabolic radio card. At 2 o'clock or so, to our immense satisfaction, the link was established with good bandwidth and latency results. Also, we proceeded to limit the emission power, lowering it so as to make it compatible with the limit amateur radio set for the autonomous repeater stations, 10 watts EIRP, and noted that it was still possible to have about 4 megabits per second actual throughput, HDX, UDP, and a good link margin. At 7 o'clock, after a rich lunch of very good wild boar sausages and some further evidence, radio test, no digestion. We proceeded to remove all the installed equipment since the stations are still awaiting authorization, final installation. Now, I have discovered that these were actually authorized and they've been running ever since. The material used was the same as in the previous link, except for the antenna. This time we're partly self-built Del Esperantissimo by this guy. Reason this additional satisfaction for the success of the company. So they were particularly proud that they built these antennas themselves. They established this connection in 2007. They waited for authorization from the authorities and then they went back and fixed them permanently. That was until 2016 when this article was posted. So this is on the Ubiquiti's forum. So it says, "Hello everyone, wanted to start off by saying that we have used Ubiquiti products for quite some time, and when we had seen what was done in Las Vegas and that we continued to see other deploy air fiber radios for long distances, it was time to upgrade our story from 2007 and upgrade it in a big way." So it says, using the sites as discussed in the article from 2007, we decided to work with Ubiquiti to achieve the same throughputs that they were achieving with their link. Using 35 dBi dishes and 2 AirFiber 5X radios, we removed the existing radio, which was achieving a few megabits per second in throughput, and see what we could get from this new technology. We went ahead and deployed slant 45 polarization and began aiming the radios using the embedded aiming bar graphs within the radio. Maximizing the bar graphs, we were able to see incredible throughputs, see picture below. The link has capabilities to jump as high as 356 megabits per second, as you can see below, while still maintaining less than 3.5 milliseconds latency. We only basically wanted to test out to see its capabilities. We don't plan to use this in its configuration, but knowing what it can do is awesome. So there's a few photos here that they took. It's from either side. Then there was another forum post or a thread that was made regarding the same upgrade. At the bottom of this thread, on page 1, it says, "Since your link does not have optical line of sight, have you thought of doing an even longer link? Corsica to the Italian Alps could make a link of about 400 kilometers. So this guy has pointed out that they don't have optical line of sight. And on the next page, this guy comes back and says, The Mediterranean Sea might add some extra variables to that link. It looks like there's a long history of favourable weather conditions for tropospheric ducting, although that's usually for lower frequencies. We regularly see it with the 900 MHz, but 5 GHz might work too. So he's using this term tropospheric ducting. So let's just see what Wikipedia says about tropospheric ducting. So it says tropospheric propagation occurs when signals are reflected, scattered or refracted in the troposphere. Ducting effects occur primarily because of temperature inversions at a height of between 500 metres and 1500 metres, and occasionally up to 3000 metres. Such inversions are not caused by local weather or terrain, but rather climatic conditions such as frontal boundaries. Temperature inversions are usually layers rather than sharp lines separating regions of different temperature. So it's saying that this tropospheric ducting or tropospheric propagation occurs not by local weather conditions, but sort of general weather conditions, large weather conditions such as frontal boundaries. And then down here it says when ducting occurs, so it's when ducting occurs, not it occurs all the time. When ducting occurs, signals travel along and within the inversion layer, reflected off its boundaries. And it gives you a little diagram here of what it's talking about. So this will be the inversion layer, and going from one antenna to the other antenna. But again, it depends on the weather front. It's not all the time. It's intermittent. And I was curious about this, so I went on the Ubiquiti website or the forum, and I posed a question. So I said, just out of interest, why are Wi-Fi transmissions limited to line of sight and therefore distances in the hundreds of kilometre ranges, whereas amateur microwave enthusiasts are not limited by line of sight and have DXs in the thousands of kilometre range for like frequencies? So DX is a terminology for an amateur radio enthusiast making a contact with another one. That's what they call a DX. It's also called a QSO. So I was just basically asking why they can do it with amateur radios over thousands of kilometres, and we can only do it over hundreds of kilometres when it's line of sight. And there was a couple of to and fro's with this guy. He helped me out a little bit with tech, but the very last post by this guy really helped to sort of nail the point. So he replied, due to tropospheric propagation, you might be able to make a QSO, that's a radio contact, with another station thousands of kilometres away. The next day, this might no longer be possible. That's fine, you made your QSO. We have completely different expectations for a wireless link. We expect to communicate over this link any day, any time. We would like it to perform consistently, not influenced by weather or any other environmental conditions. These expectations impose some practical limitations, line of sight being one of them. So this is the design guide for the AirFiber 5 radios, and this is a document called the Best Practices for Installation of the AirFiber AF5. So, selection of installation site. For best performance, you must install the AF5 as high up as possible with line of sight free from obstructions. Let's go to another document. This is the quick start guide for the AirFiber 5X. And installation requirements. Clear line of sight between AirFiber radios. So it's pretty much a prerequisite that there must be clear line of sight. They say it unanimously in every single one of their model of antennas. So let's go ahead and punch the numbers into the Earth curve calculator and see what all the fuss is about. So we know we've got an eye height of 1300 meters in the Sardinia side, and it's a distance of 304 kilometers. So calculate. We have a target hidden height of 2,411 meters. So let's go ahead and punch that into the calculator. We'll subtract the height of the Italian site, which is approximately 1,738 meters, and that gives you 673 meters of hidden height. So this has to beg the question, why are they testing these? If atmospheric conditions are required for these transmissions to take place, and they know that it's behind 673 meters of curvature, what would be the point in even testing them? We know they're not designed to be intermittent and be dependent on weather conditions. They're designed to be rock solid, stable. The data sheets all say that they need to be clear line of sight. So what is the point in testing these things behind Earth's curvature and relying upon weather conditions? Well, this is where it all gets a bit strange. So I'm going to go on to the software that the Italians used to simulate the link back in 2007. So you'll remember this document that I showed earlier, and it shows the simulations here of the link. And if you scroll right down to the bottom, there's another one here, and it gives you all the settings that they used, all the parameters. So this is a software called Radio Mobile, which is a web-based application. So I created an account and I duplicated the link, and indeed it does actually show a clear line of sight between the two sites in question. The green line in the centre being the line of sight, and it also shows that the two white lines here, which are the first and second Fresnel zones, they do actually clear the Earth's surface. But it is wrong, and if you do the hand calculations, which we did earlier, or rather on the Earth curvature calculator, it shows that there's clearly not a line of sight. The Earth should sort of curve right up here. So there's obviously something wrong with this software, but it only seems to be these two particular sites. I've tried it in multiple other locations around the world and it seems to work fine. It's purely just this one. So if the Italians didn't use an Earth curve calculator or do hand calculations, and they purely relied on this simulation, then indeed there would be no reason for them to doubt that it would be a viable link. So it's quite strange that this is the only location that is wrong, and it is wrong. So let's move on to Ubiquity's version of this software, because there's some strange goings on with that as well. Okay, this is Ubiquity's AirLink calculator, and it's web-based. I'll provide the link in the description. But I've simulated the link using their equipment, and if you scroll down here you can select which equipment you want to use, what gain, what output power. So I've selected the correct equipment that was used, and if you can place a transmitter and a receiver in two locations. You can set the tower height, the antenna height. This one's set at 8 meters, this one's set at 14, and you just drag this icon up and it increases it. I found that information from the document referenced earlier. It automatically knows the elevation of the two positions, and it provides you with a simulation on the left here. But as you can see, this one says simulation error. So I just want to give a little demonstration of what happens when you move these antennas to anywhere else in the world apart from Italy and Sardinia. So let's drag this one up for a start up here. And we'll look on the left. Now it's giving us a simulation. It's showing us the curvature of the Earth. It's showing the heights of the towers, and it's showing that the link would be completely obstructed, link obstructed, because of the curvature. Let's move that back now to Sardinia, not to the correct exact location, but just in Sardinia. Simulation error. Now let's move the one in Italy. If I can grab the dot. There we go. Let's move that right over there. So we've got a distance of 2,200 kilometers. Again, it's giving me a simulation error. It's telling me it's completely obstructed. Let's move that one back to Italy. If you'll let me grab the dot, there we go. simulation error. It's done a simulation now, but it's obstructed. Let's just move them nice and close together. You can see the curvature of the Earth's gone down here now. It's still obstructed. Let's just move them a bit closer. There we go. You can see there's almost a completely clear path now. And just for verification, we'll do it once more back to Italy and Sardinia. And I haven't done it to the exact locations, I've just done it to roughly the locations, and again, simulation error. Now, previous to this, I emailed Ubiquiti and I offered to carry out some tests for them over long distances and at low elevations over sea level, you know, so that we could sort of test their equipment to the limits. And I specifically referenced the Italy to Sardinia link that they'd already done, and then about a month later, when I tried this again, this simulation error occurred. Previous to this, it did work. It gave me the simulation, albeit it was completely obscured by the curvature of the Earth. It did actually give me the simulation. So since me writing my email to them, they have disabled this a simulation being possible from Italy to Sardinia. Now, during the making of this video, I stumbled across this page, which is quite funny really. Long-range Wi-Fi, Wikipedia's page on long-range Wi-Fi. So if we click on it and we scroll down to the section that's called notable links, here we go. It describes the link in question, and the second sentence here, it says, it appears to be permanent from Mount Amiata to Mount Limbara. So this was the first link established in 2007, and then they updated it for the 2016 upgrade, and again it appears to be permanent from Mount Amiata to Mount Limbara. So what they're saying is they've got a permanent link around the curvature somehow. Not quite sure how that can possibly occur, but nonetheless that's what it says here. And I'm going to monitor this wiki page quite regularly now, because you can bet your bottom dollar that these two bullet points will probably be deleted after I release this video, which will be very telling, but I'm going to keep a close eye on it anyway. So now let's go back and piece together the puzzle and ask ourselves the question, is there a deception going on here? So we know in 2007 that the only parties referenced as being involved were Ubiquiti and CISAR. So CISAR, the amateur radio engineers, they are a non-profit association founded by a group of Italian radio amateur operators in 1981. Their main activities are in VHF and upper band experimentation, and they successfully interconnected the entire of Italy with FM and digital repeaters a few decades ago. So it's therefore safe to assume that although these guys come under the banner of amateur, they are very capable and well versed in microwave equipment and the transmission of microwave signals. And at this point, we have no reason to believe that CISAR intended to deceive anybody. So Ubiquiti are manufacturers of wireless communication products. This case study, published by Ubiquiti, claims that they provide Wi-Fi to 2/3 of the UK's military personnel. So obviously the military is a large client of Ubiquiti. And we know from all the Ubiquiti datasheets that a clear line of sight is a prerequisite in any of these installations. We know that atmospheric propagation or ducting occurs only in certain general weather conditions such as frontal boundaries. We know that the Earth is supposed to be curved at 8 inches per mile squared. We know that in this link there is 673 meters of hidden height if the Earth is curved. And we know that this is a permanent link, and it was established in 2007 and ran up to 2016, when they upgraded the equipment for quote-unquote experimental purposes. In 2016, there becomes mention of some other institutions involved in the experiment, namely the International Centre for Theoretical Physics, or ICTP, where they have an article on their website stating their involvement as coordinating the scientific features. Other parties cited as being involved are the United Nations Educational, Scientific and Cultural Organisation, UNESCO, and the International Atomic Energy Agency, IAEA, and the Italian government. So at this point, with all the parties involved, it seems to me to be inconceivable that no one would have realised that the installation was not line of sight. So prior to Ubiquity's own Airlink calculator, there was a calculator called Radio Mobile. And Radio Mobile is probably one of the most popular tools to perform link simulations, especially back when they first did the installation in 2007. And we know that CISAR referenced Radio Mobile and definitely used it, and they put some of the images obtained into their PDF document in 2007. We know that the simulation produced by Radio Mobile is wrong because it shows a clear line of sight between the two sites, whereas on a globe of the purported size it is, this is not the case. The error between these two sites remains to this day on the Radio Mobile software, and in my opinion would need to be deliberately programmed that way. It cannot be a calculation error, as everywhere else on Earth works just fine, at least aboard parameters anyway. So this error would need to be introduced manually, but by whom? I've emailed the address given on the Radio Mobile website and queried the error, but no response has been received to date. Make of that what you will. So it would appear that CISAR may have been duped into believing that there was a clear line of sight, as verified by the induced error in the Radio Mobile simulation. The calculator was, and still is, a reputable simulation tool, so why would they doubt it? After all, it's not like they were shooting thousands of miles across an ocean, which would probably raise questions. Instead, they were asked to install them on relatively tall mountains at a distance where the curvature could not be conceptualized easily in your head. So the question now becomes, were Ubiquity, perhaps at the request of the military, or by one or more of the other institutions involved, knowingly testing long-distance Wi-Fi transmissions at distances that should be impossible? Are there obvious military applications for shooting Wi-Fi signals over such distances? Is it really believable that no one involved in the project for 11 years from 2007 to present day knew that the link was not actually line of sight? Is it believable that the Radio Mobile calculator contains a genuine error for that location only? Is it a coincidence that shortly after I contacted Ubiquity to offer to assist in testing their equipment and referenced the 304-kilometre world record, that they disable the ability to run a simulation between those locations only? Is it conceivable that the military or any of the other institutions involved would want to test the latest Wi-Fi technology over long distances without raising suspicion that they were shooting beyond the curve? And finally, is it possible that a microwave signal can propagate permanently around a curve regardless of weather conditions? Wikipedia at this point would certainly attest to this. In my opinion, there is no way that out of all the parties involved, none of them knew that this link was beyond the curvature, and from a globe perspective, the whole experiment was a major waste of time and effort. As mentioned earlier, line of sight is a prerequisite for any microwave installation, and nobody in their right mind would try to perform an experiment over the curvature and try to obtain a permanent stable link. From a flat Earth perspective, however, the results are very telling and a compelling reason to carry out further testing of this nature, but at much lower elevations over the ocean. And in association with FE Core, we will be doing just that over the coming months. So get yourself across to the FE Core website and join if you can. And as always, thanks for watching, folks.